why you want to do the reversal. So we're going to look at the homework, starting with D28 in the ACE problems for page 14 on, right? So these are the covering and surrounding ACE problems. Isn't that the name of this book?
Yeah.
I can't even, pages 14 to 32. Okay, Kaden, questions? Papers to turn in? Okay, I'll get you the folder. So when you look at problem 28, the question is to figure out the dimensions of what? What's it ask?
Of a shape with the area of 20.
It's in the crate in the back. Okay, the dimensions of a shape with the area of 20 square meters. Okay? So you're supposed to come up with the dimensions. And Antonio?
When it's saying this stuff on 27, 20, I don't know.
Okay, so we're going to start with 28 because they all work the same. So the word dimensions means, so when you see the word dimensions, that's, for starters, you need to know. That just means the length. There's a T in there, by the width. Oh my goodness.
Should we take notes?
We've done notes on this, so it's up to you if you want to do more notes or if you want to listen, follow along. I'm going to record it. So if you have an area of 20, think of all your factor pairs. All the ways you can get 20. 1 times 20.
Oh, it's right up there. Yeah.
Yeah, they're up there. So 1 times 20 or 2 times 10, right?
4 times 5.
4 times 5.
5 times 4.
You could go back down. 5 times 4. And the difference there is these are all dimensions of a rectangle. So like a 1 by 20 would be really long and skinny. Okay? A 2 by 10 wouldn't be as long, it'd be like that. And then a 4 by 5 would be more almost close to a square, right? So my pictures aren't perfect. But the idea is this would be 1 by 20. This would be 2 by 10. This would be 4 by 5. So if I kept going, 5 by 4, 10 by 2, and 20 by 1, then your 20 by 1 would just be a rotation of a 1 by 20. In other words, the 20 by 1, it's not letting me capture it. The 20 by 1 is just like that. Do you see the difference? So they're rotations, okay? So on problem 27, 8, and 9, you have to first figure out the length, the width, and the perimeter. They give you the length, you have to figure out what, or they gave you the area, and you have to figure out all the combinations of length and width that give that area. So the first thing is to figure out like a 1 by 20, and then think about the picture, and if you have that picture, then your perimeter would be adding up the 4 sides of that picture. So this is 1, and this is 20, and this is 20, and that's 1. Adding up the 4 sides gives me a perimeter of 42. Does that make sense?
Yeah.
Do I need to draw every single picture?
No.
No. Because really, aren't I just adding 1 and 20? And then adding 1 and 20 again? So couldn't I just add 1 and 20 here and then double?
Yes.
So 2 plus 10 is
12.
double it, because that's perimeter. It's adding up all 4 sides. That's one part of the question. Raise your hand if that makes sense. Okay. So then it asks you to do a graph, right? A graph of length and perimeter. For rectangles, of area equal to 20 meters squared. Okay, so I have to plot points. So when I make a graph, I have to think about how I want to do the spacing. And so for perimeter, that's going to be on the vertical. The perimeter is going to be along this axis here. Okay, I have to go at least how high?
42.
Good, Connor. So what would be a reasonable thing to go to?
45.
45 or 50, right? So you look at your graph paper and kind of see what you have. If you count increments here, I'm going to go to one page because it's a little fussy when I'm at 2 pages here. So if I see if I can count, my board's not working, so let me pause this and do orientation. Okay, so now let me see if I can do this. So I'm going to count my spaces. 2, 4, 6, 8, 10, 12, 14, so 16, so I have 32 spaces there, right? So, yeah, so maybe if I just count by, yeah, I could even just count by 5s and just use like 10 right here. 10, 20, 30, 40, 50. I could spread it out more, but I don't really have enough to count by 2s, and I think if I go up to 50, you could still see the top of the graph without me scrolling back and forth, so I'm going to stick with that. So when I go to 2 pages, I'm going to go back to 2 pages to see how big is my biggest length. 20, right? So I have to go to 20. Carson?
Well, I'm wondering since, so 4 and 5, they're in parallel 18. So you have to do 5 and 4, like 5 times.
You have to do both of them. Alright. So I'm going to go up to, again, I'm going to count my spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to make that 20 and count by 2. You see what I did there? 2, 4, 6. Yeah, makes sense?
Yeah.
So I've got some nice graph spacing. Now I'm going to plot my points. I'm going to go back and look at my chart. I need to look at my chart so I know where to put my points. Masani.
Why is the length 20? Why does it go to 20?
Because
Just the height. Oh, okay.
I got that from my chart.
I see.
Okay, so I'm going to plot my first point, which is right here, a 1 by 20. And I don't have a 1 increment, so I'm going to go halfway between 0 and 2. But I know for a length of 1, I have a perimeter of 42, so I go up to 40. Right here would be 45, so 42 would be like right about there.
Not quite halfway.
Yeah, not quite halfway. And so then I'm going to label that point 1 by 42. And the reason we label those points is because I don't have a grid marker on every single place. So now I'm going to go to my next point, which is 2 by 10. That's an easy one. Oh no, 2 by what? What's my perimeter? Because I'm graphing length versus perimeter.
24.
2 to 24. So 2 by 20 would be here. That's 2 by 25. So 2 by 24 would be like right here. You see that?
Yeah.
Okay.
I don't see why you have 1 by 42 instead of 1 by 20.
Because it's length versus perimeter, not length versus width.
Oh, okay.
Okay? Antonia.
Wait, so are we supposed to do the graph?
You were supposed to make a graph. You might have to make that up. It's probably hard to do that while I'm talking about it. You can work on it. So 4 by 5 would be right here.
4
That
by
one,
18, isn't it?
oh, 4 by 18. See, I knew I was going to do that. 4 by 18, so I need to move that up to here. Thank you for catching my mistake. And then 5 by what? 5 by 18. Because for a width of 5, you still have the same perimeter. So this is 5 by 18, so I'm labeling my points. And this one here was 4 by 18. And then 10 by what?
24.
24. 10 by 24. The length of 10 is a perimeter of 24. So right about here. And then the last one,
20 by 42.
20 by 42. 20 by 42. So right here.
That's 30. That is like 48, isn't it? Yeah.
Oh, okay.
Up one more
Oh,
script.
thank you.
Yeah.
I'll move that. Well, the smart board, I can just pick up the dot and move it.
It's
Okay.
door.
Pardon me? Sure. Then you have to put your curve in. So when I put a curve in, I tend to use dotted lines first to kind of make sure I hit my target points. Because I have a problem sometimes hitting my target points. I don't know if that ever happens to you guys. You just miss. Do you ever miss them?
But you can still make a perfect circle.
All right, I can still make a perfect circle. What's up with that? So I'm going to put my curve in now. Now that I put the dotted line in. And I've got my curve. And now I can start answering questions. Okay? So the questions start to ask me, like, what is the perimeter for a rectangle that has a length of 2? Is that one of the questions?
No, it's 32. With a rectangle with a perimeter of 32.
What is the perimeter of a rectangle with a length of 2? That's number letter A. 28A. 28A asks for the perimeter of the rectangle that has a length of 2. So we could get it from our chart. The perimeter is 24 meters. But we can also get that from our point. Do you see how to read the graph? Wyatt.
There's no 28A.
Oh, my.
No, it says, it just said,
I'm on the wrong page. I did the A for the next page for 30. Okay. So for 28A, I already did the rectangle pictures, and I made a graph for B. So for C, but then let's not call this A. Let's look at that question though. That's important. You should be able to answer a question like that. Can you tell me the length and width if I tell you the perimeter? Like if I say the perimeter is 42, can you tell me the length and width, Connor?
Yeah.
What is it?
20 by 1 by 20.
No. Yeah. Okay, so what if I block that off, and now I say the perimeter is 18? Can you tell me the length and width from the graph?
4 and 5.
Perfect. Okay, look at what he did. How did you do that?
Well,
Perimeter is what?
perimeter is
18. So go to 18. See the perimeter here? So he said 4 and 5. How'd you get that?
I subtracted 5 plus 4, which is 9. 9 out of 18.
Okay, so he's visualizing a rectangle. So if this was 4, he would know this is 4. The perimeter is 18. So 18 take away both of those 4s is 10. Divide it in half and you get 5. But Connor, did you notice the 4 and 5 are right here? So you could also even do it without the subtraction. So if I said the perimeter was 24, what's the length and width, Kate?
2 by 10 or 2 by 2.
No.
24 perimeter? Or what? No.
So if the perimeter is 24, what's the length and width?
the length and width of 24?
So here's perimeter. That's why I'm asking.
Yeah.
So it tells us the length is 2. So this would be 2 and this would be 2. That's a really bad rectangle.
That's the width. That's the width. What not?
Okay.
Oh, that's yes.
Gotcha. I see why that's bothering you. So 2 by something. But we know that the perimeter is 24. So if we take 24 and subtract both of those 2's, we get 20, right? We have to break that into equal parts, so this is 10 and this is 10. You agree with that?
Yes.
So it's a 10 by 2. Now look, here's the other 24, right? The dimensions are right here, 2 by 10.
So that's why you
10 by 2 or 2 by 10.
That's why you do reversals.
Did you say that? I just didn't hear you. So then, for the perimeter of 42, Kate, what are your dimensions?
1 by 20.
1 by 20. Does everybody see how to do that?
Yeah.
Maybe 2 ways, right? With the picture or with the graph. With the picture of the rectangle or with the graph. So Antonio, on 28, that's all the things they're asking you. So when it says describe how you can use the table, that's what we're doing right now. We would look at this. We use the table to find the rectangle with the greatest perimeter. We look for the biggest number. And then it says describe how you would use the graph. Then you would find the rectangle with the greatest perimeter by going up perimeter and finding the highest perimeter, which here is 42. That's the highest point. And then the dimensions of that are 1 by 20. Does that help?
Yeah.
And if that's hard, and the better way for you is just to know that it's a 1 by something. Like you just know that there's a 1 in it, because you can read that it's 1, and you know the perimeter is 42. Can you find that information on the graph? So this coordinate is a length right here, length of 1, that's the first thing, and the perimeter is the second thing. So the length is 1, the perimeter is 42. So I'm putting a 1 here and a 1 there. Okay. It could be drawn, remember that they are making, this could be rotated sideways too. It could be long and skinny, right? 1 and 1, and we would still have the same missing number. So I take that 42 and I subtract out both of those 1s, and I get 40. And I have to divide that into equal parts to get a perimeter of 42.
Wait, so the one on the top, you always multiply pairs?
Yeah, so the number on the top, I doubled it, because there's 1 on the bottom and 1 on the top. Subtract it from 42.
And
Then you have to get this number and divide it into 2 parts.
yeah.
And that's where you get 20. And now your 4 numbers, 20 plus 1 plus 20 plus 1, should add up to your perimeter. And if you look at your graph over here, it tells you, that's what the graph, if you can learn to read it, tells you it's 1 by 20. See, the numbers are right there.
That's another good way why you should do reversals.
That's why the reversals are important. So I said earlier I was going to explain why you want the reversals, the rotations, because you get all that information from the graph.
On this start assignment, did you take the point off?
You should color and put it in. I'm going to expect you to do reversals. So,
I tried.
but do you understand it better now?
Yeah, I tried the reversals.
It's because when we did factor pairs, we always stopped when there was a repetition, right?
Yeah.
But now the repetitions have a meaning, so we keep going. The repetitions have a slightly different picture. It's the picture rotated.
I need a refresher on the fixed perimeter.
Okay, so let's go to the fixed perimeter.
That's 31.
This one, right?
31D. No, 31D. 31.
Okay, this is the picture though, right?
Yeah, that's the picture.
So the important thing is some of the properties are the same. Like you could still hit coordinates. For example, this point right here is one, like two,
That's like one.
how about this one? This is an easy one to see. 224. And the one way over here
Is 24
is 1224. You want to check for me?
Yep. It is.
Okay. And this one looks like an easy one to get. What are those 2 points?
35. No.
440.
440. And 1040. 10, 12, 40.
10. It's 10.
1040. Also, another word is.
So Masani dropped down.
Yeah.
Oh, she was right.
11.
Oh no, I'm looking at this one. Right there, right?
Yeah.
1040. Right there. Okay. So the questions about this is, if we looked at these problems, this is 31, right? So 31 says, what's the area of a rectangle with a length of 2 meters? That's the one I was reading earlier. So the length is across the bottom. So go over to 2 meters and then read to here, and that's go to the 2 meters and then read across, and that's your area. So the area is 24. Do we understand that? And so if you looked at that picture, it would be, you know, a rectangle that was 2 by something that has to give an area of 24. So 2 times what?
12.
Is 24. 12, right? So that has to be 12. What's the perimeter of this picture? Yeah, Wyatt. 28. Do you see where he got that? The perimeter, he added up 12 plus 12 plus 2 plus 2. So 24 plus 4. Perimeter
28.
is 28. 28 meters. The area is 24 meters squared. Okay, so we know the perimeter is 24. Okay, well, let's look at this picture here. This is a 10 by something. So this one says, this says, if my length is 10, my area is what?
40.
40. So 10 times what is 40?
4.
4. Oh, so look it. My picture looks wrong, doesn't it?
I was thinking about
It should be like that.
Yeah.
Right?
Yeah.
Okay, what's the perimeter of this? Okay,
28.
28. 10 plus 10 is
20.
20, and 4 plus 4 is?
8.
So it's 28 meters. What was the perimeter of the other one?
28 meters.
28 meters. So when you see the title here, fixed perimeter, what's the perimeter of every rectangle here?
28.
28.
Oh.
That's what it needs to be fixed. Should we just check one more? Let's check, how about this one right here? This point, if I scroll all the way down, is 6 by,
5, 6.
so the point is 6 comma 48, right?
Yep.
And I'm kind of needing space here. So it's 6 by something gives me an area of 48. So 6 times what is 48?
8. Yes, 6 times 8.
Good. 6 times 8, right? So what's the perimeter then? Okay, that's on it.
28.
How'd you get that?
I added 8 plus 8, which equals 16.
8 plus 8 is 16.
6 plus 6 equals 12.
So 16 plus 12, 28. 28 meters.
Yeah, I was just brainwashing on that.
Or she just knew fixed perimeter meant they should all be the same, right? But we were checking, so the perimeter of every single dot, every single rectangle that's represented by a dot there has
28.
a perimeter of 28, so that's part D. Peter.
Well, couldn't we just do one of them because we know that like.
Absolutely. Well, what is the drawback of figuring it out once?
You might have gotten it wrong.
What if you got it wrong?
First time.
Check yourself if you do it another.
Do a few of them. Make sure you're getting the same number over and over and over. Antonio.
Should we go over?
Yeah, describe the dimensions and shape of the rectangle that has the greatest area represented in the graph. So again, you're gonna look like, I'm gonna zoom out a little bit. Remember areas on the left? See that?
Yeah.
So you're gonna go to the highest dot, which is right here. That's the highest dot. Now read down. And it's 7 by something. Do you see where I got that? Really?
Mm-hmm.
So we know that the greatest area, if you guys didn't see that, I found the biggest dot. Oh, that's too fat because it needs to be thinner to be effective. All right.
Wait, are you using a straight line tool?
I was using the highlighter, and the highlighter acts as a straight line tool.
Oh,
So
wow, there's lines.
I found the biggest dot, the highest dot here, and I project it down on the grid. And I see that it falls right between 6 and 7, which is my 6 and 8, which is my length. So my length is 7. 7 times something. So 7 times something has to be 48.
It's 8.
No, 7. Yeah.
Oh, it's not 48 though, is it? It's 49.
It's a little bit
Yeah,
over.
so it's 7 times 7.
A little bit over 48.
Yeah, it's halfway between 48 and 50, isn't it?
That's why you need to square. It's a square, not a
So
rectangle.
then my picture, even though my picture kind of helped my thinking, when I see the actual numbers, it should be more like this, right?
James.
It's a square.
It should be a square. So the answer to part B I would describe this as a 7 by 7 square. It's a square with dimensions 7 by 7.
But technically, squares are forms of rectangles.
Right, a rectangle with equal sides. Genevieve.
Another way you could figure it out is because since there is like the points and like what we're doing for like 2, 12, that means that those are the
Right.
dimensions. But since there's only one of them, that means that it must be by itself.
That is so smart. Listen to what she said. So, okay, first person of the day that came up with that. Do you remember what I was trying to show you guys? That if you look, say, at these 2 points right here, they both have a perimeter of 40, and the dimensions are 4 by 10.
Yeah.
Right? And these 2 down here both have a perimeter of what? And the dimensions are 12 and 2.
Oh my gosh.
So this one only has 1 dot. So it has a perimeter of 49. So the dimension must be 7 by 7. Because it only, this is 749. And there is no other 749 to pair it up with. So it has to be that this 7 is both the length and the width. Smart. You notice that? It makes sense, right? Like this one over here is 848, right? That's a funny 8. So the dimensions must be 6 by 8. But this one's right in the middle. 7 by 7. Good job. Okay, so those are big problems. Those are big thinking problems. We probably don't have a lot of time to do 51 today. But we should do 51 tomorrow because that's also really important. But I can tell you the answers.
Thank you.
51 is 8. 51B is 16. And 51C, 6. 6.
What about 56?
56. There is many. The answer is yeah. You can find perimeter, but there's not one solution. So if we look at 56, and they tell us that we know there's an area of a rectangle that's 120 square meters. You guys, I can write square meters like that. Did we talk about that?
Yeah.
I don't know if we did. That means square meters. They're asking you if you can find the perimeter. Well, there's more than one solution because there's so many rectangles. Like you could have a 10 by 12. And so then that perimeter,
You can have a 1 by 120.
what would that perimeter be?
That'd be 40 or no,
244. 44 meters, right?
You could do 1 by 200.
I just.
1 by 120.
You could do.
I got 30. I got
Okay.
30 by 4.
1 by 120, right? So
242.
so that perimeter, right. So there's lots of different correct answers. Haley, I'm going to stop it there.
Wait, 4 and 34.
Yes.